I find it when I was preparing for this discussion, I find it quite difficult to organise my thoughts because so many things lead into others. And you just mentioned there, we're not sterile when we're born, but a lot of people, I suspect, watching this show will be thinking, well, one of the very important elements of the microbiome is vaginal, and as the baby is delivered, it picks up the mother's bacteria and so on, which is healthy in developing its own. And I suppose leading on from that is the question of, well, surely they must be getting bacteria they must be sharing the microbiome with their mother while they're in utero as well, by one mechanism or another. But what happens to those babies which are delivered by cesarean delivery, for example?
Yeah. So I think that there's quite a lot there, and I think it's probably worth unpicking some of what you said because there's some really important themes within it. So I think the first thing to say is that what we're beginning to understand is that because the microbiome is so dynamic through our ages, how the microbiome is set up in early life, maybe even the impact of the maternal microbiome on us as we're gestating, is so important in defining our risk of chronic diseases in later life. Therefore, if there's a problem in the assembly of the microbiome in our very earliest parts of our lives, maybe even the first 100 days, the consequence of that might be very, very long lasting. Now, traditional science, traditional medicine teaches something called a sterile womb hypothesis, which basically states when you're born, you're completely sterile. You have no microbes within you or on you, and then you're colonized through the delivery of the birth canal, and then through breastfeeding, and then through your introduction into the world. But we're beginning to sort of challenge that hypothesis. And these sorts of scientific challenges are really difficult for many clinicians to grasp because they are so challenging in terms of our understanding of basic science. So traditional basic science says, of course, microbes can't cross the placenta and they don't get into the gestating infant. The first thing to say is that the maternal microbiome can influence the baby's development without needing to do that because it produces this very large array of small molecules which can happily cross the placenta. So metabolites, that's what we study, or proteins or other various kind of immunological molecules. And these have a very important role in shaping infant health. But also we know from the second trimester that very, very low abundances of these microbes can be detected in an infant gut. And more importantly, their T cells, so they're parts of their immune system that you can culture out, actually seem to already have a memory to these bacteria, and that gives us some evidence, at least, that maybe these microbes are actually abundant and they're present in very, very low abundances within infants at a much earlier stage than we had thought. And the significance of that, well, one of the most important significant issues with that is that I think about the microbiome as the puppeteer of the immune system. It educates the immune system, both the innate and the adaptive immune system. And if, therefore, the microbiome is not functioning properly, it's not signaling to the gestating infant properly, it's not assembled in early life, that means your immune system can't be set up. And if your immune system can't be set up properly, then that leads, we think, well, it's a sort of core mechanism that underpins many of the risks of chronic diseases that we see.